Hey everyone, welcome back. Again, we have this type of integral whereby the denominator is a trig expression. But before that, I'm Domingos. I'm also known as DMA and appreciate when I'm called DMA. So for this particular case, whereby we have the denominator as a trig expression, but for this case, our exponent is no longer 1. So if it was 1, then we will have let tan of x over 2 to be t. But for this particular case, we have cos cube and we have sine x. So that means we're going to let simply tan x to be equal to t. No longer tan of x over 2 because there is exponent different than 1 in one of the trig expression. All right. So if we say tan of x is equal to t, what will be the value of sine x and cos x? Because we are not given tan x. So for this particular case, then we can demonstrate. So we know that cos squared of theta plus sine squared of theta is always 1. When the argument of cos is the same as argument of sine, then that means cos squared of that argument plus sine squared of that argument will always be equal to 1. So if that's the case, then we can say that sine squared of x is equal to 1 minus cos squared of x. All right. So if we have this is true if we isolate sine here, but we're working with x because our problem is with x. We know that every expression is always divided by 1. There's always one that we can't see. So if there is always 1, then it's not a problem if we say 1 minus cos squared of x over sine squared of x plus cos squared of x, because according to this formula, this will still be 1. This is still 1. What we can do, we can now divide both of expression by cos squared. So if we divide whether the numerator and the denominator by cos squared, here we're going to have 1 over cos squared of x, and here will be 1 because cos squared over cos squared is 1. Here will be sine squared of x over cos squared of x, and here will be plus 1. So we can find the common denominator here. Then we're going to have sine squared of x will be crossing and multiply 1 minus cos squared of x over cos squared of x over sine over cos is tan, so we're going to have tan squared of x plus 1. 1 minus cos squared is sine. So that means sine over cos is still tan. So we're going to have in this particular case that sine squared of x will be equal by tan squared of x over 1 plus tan squared of x. So if we isolate this, then that means we're going to have sine x will be square root of that expression. So will be tan x over 1 plus tan x squared in the square root. But we say tan x is t, so that means sine x will be equal to t over square root of 1 plus t squared. All right. So if that's the value of sine, then what will be the value of cos? We can still apply the same procedure. We can just isolate cos squared will be 1 minus sine squared over x. Okay. So what we can do now, we can apply the same procedure. We can divide both expression by cos squared. I mean the numerator and the denominator, right? So if we do so, first we have to consider cos squared plus sine squared is dividing by cos. What we get, we have 1 over cos squared of x minus sine squared of x over cos squared of x. Divided by cos here, it's going to be 1 plus here it's going to be tan squared of x because will be sine squared over cos squared. They have the same denominator. If we keep, we're going to have 1 minus sine squared, which is cos squared. So the numerator will be 1. So that means we're going to have cos x will be square root of 1. It's simply 1 over square root of 1 plus tan squared. But we said it's t, so it's going to be t squared. All right. So this will be the expression for sine, and this will be the expression for cos in this type of problem. All right. Okay. So after we deduce the sine expression, cos expression, it's missing now dx. What will be the dx? Dx we can simply isolate here. Then we're going to have x will be inverse tan of t. So if we differentiate both sides, dx will be the derivative of the argument is 1 over 1 plus the argument squared. So that will be the value for dx for those type of problems. Now we can simply substitute where there is sine of x by this expression, where there is cos by this expression, and where there is dx by this expression. All right. So if we do so, then we're gonna have this will be dt over 1 plus t squared. All right. Now over square root sine. Sine is this expression, so we have t over square root of 1 plus t squared times the expression for cos is this expression 1 over square root of 1 plus t squared, but remember cos is to the power 3. That's the expression that we get for cos. Right, let's continue. Carrying on, that means what are we going to have? We're going to have the integral dt over 1 plus t squared, all this over. If we multiply the denominator for these expressions to the power 3, then that will be to the power 4. So we have square root of t over square root of 1 plus t squared, all to the power 4 dt. Right. So if that's the case, we can simply have this integral will be dt over 1 plus t squared over, we can separate, so which one with the square root, so we're going to have square root of t here, and then we're going to simply have square root of 1 plus t squared all squared, because it cancels with the main square root, and this one can also cancel out, so we're just going to be having like this. Without square root, that square root disappears as well. Now, if we multiply the first expression by the inverse of the second one, then we're going to have, this is dt over 1 plus t squared, and then we're going to have 1 plus t squared over square root of t dt. And then we can simply simplify it as 2. Then we have integral of t to the power 1 over 2 dt. So since came from the denominator will be negative. Now we can add 1, so it's going to be t minus 1 plus 1 over minus 1 over 2 plus 1. So this will be 1, so it will still be t, and this will be 1 over 2. So this will be 1 over 2 in the denominator as well, which inverting is the same as 2. So this is 2. So that means we have 2 square root of t, which is equal to 2. What is the value of t? It's 10x. So square root of 10x plus c. So this is the answer for this integral. Okay. So if you enjoy, leave your like, your comment, subscribe, and most importantly, share with your friends.